For lesson 3 of our expressions unit, we'll be talking about evaluating expressions. And we keep saying this word expression. An expression just contains numbers, variables, and or operations. So a bunch of different things combined together to express something, like a phrase or a sentence in English, but written with math instead. Okay? So there's a little joke here, just to kind of give you the idea of this other word, which is evaluate. So what you're doing is filling in this case, the shapes to read the whole sentence. For our joke, I'll give you a second to try it out. And now here's the answer. So all the triangles are the letter T, upside down triangle. And then all the squares are the letter R. And then the circles are the letter E. Anytime we saw a certain shape, it matched with a certain letter. And our answer is, what's the king of the pencil box? The ruler. So let's try to slowly move this over to math. So this time, instead of filling in the sentence, we're going to turn it into numbers. We're going to turn the shapes into numbers. We have triangle means 24, circle means 8, and square means 4. So if I was going to solve this, it's 24 divided by 8 plus 4. And we can use our order of operations. 24 divided by 8 is 3, plus 4, and we get a final answer of 7. And then for the next one, still the same key, so triangle, 24. Anytime you see a circle, that's 8, and anytime you see a square, that's 4. Now the parentheses have moved, so we're going to do the 8 plus the 4 first, which is 12. Copy the rest, 24 minus 12. Final answer is 12. Okay? Now, in math, it's not shapes being replaced by numbers. It's a letter that stands in place of a number, and we call it a variable. So, just like these shapes stood in place of a number, in expressions, we use variables or letters to stand in place of a number. Okay? And a variable, just like these shapes up here did, represents a specific number in each expression. So, just like whenever we saw a circle, that meant 8. In the case of number 1 here, whenever you see X, that means 7. X is always 7. In that case, I could go to a new problem and change it and tell you that X is always 2, or X is always 7.51. But I have to tell you that for each individual expression, or give you some kind of instruction so that you know what that variable stands for. If you don't know what the variable stands for, you're probably dealing not with an expression, but with an equation. And that's what we'll be talking more about in Unit 8, the next unit. Okay, so typically with expressions, you either know what the variable stands for, or you're not trying to find out what it stands for. You're just writing the expression to describe a word problem, to describe a scenario given to you in a problem. All right, so we'll leave solving equations up to our next unit. We're not quite there yet. All right, so to evaluate means to fill in and then calculate the answer. So basically fill in and then PEMDAS, order of operations. So fill in and calculate. All right, so for number 1, we have X plus Y plus Z with parentheses around the Y and the Z. Anywhere I see an X, I'm going to fill in 7, like it says right above. Plus, parentheses. Anywhere I see a Y, I'm going to fill in a 3, copy the plus sign, and then I see Z, which is 2, and there is my filled in expression. Next step is to calculate. So 7 plus 5. Did the parentheses first. Final answer, 12. For number 2, this says Z and then parentheses X. That notation of parentheses means to multiply. So it's another way to write multiply. You can say x, you can say dot, or you can put parentheses around it. So z times x plus y minus z. So I see a z, which is 2. I'm going to change it to a dot for multiply. X is 7, so I'm just filling it in. Copy the operations. Y becomes 3, and then copy the operation. Z is 2. We have to multiply first. So 14 plus 3 minus 2. Just go left to right. It's going to be 17 minus 2, which is 15. Okay, for number 3, wherever you see a y, you fill in a 3. So 3, and then keep the squared. Keep the operation in the middle. Z is 2, and z is squared, so 2 squared. Remember that the squared means that number times itself. So we're going to get 9 minus 4, which is 5. Okay, so evaluate means to fill in and then calculate the answer through order of operations like we did in lesson 2. Number 4 has another new notation for multiplication. 7x plus 5y. When you write a number next to a variable, that means multiplication. And we did talk about this at one point, and we used this word coefficient. We're going to get into that more in a few lessons down the road from here. But when you write a letter and a number next to each other, it means multiplication. So technically, there's an invisible multiply sign in between these. That's important because when we evaluate, we're filling in the number, and you can't write a number next to another number without an operation in between, unless you mean that you want this to say 77, which is not what we mean. We want it to say 7 times x, or 7 times 7, plus 5y. We don't want it to say 53. We want it to say 5 times 3. So variable next to number means multiplication. And when you evaluate, you need to make sure that that operation gets written in. So now we can just go ahead and do our 2 multiplications. 49 plus 15. We're going to get 64. Okay, number 5. Z squared plus 9y minus 3x. Again, write in your invisible multiplication dot if you need it, so that you don't forget that it's there. Z squared, so now that's a 2 squared. Copy the plus sign, copy the 9, times y, make sure you put the dot, minus 3 times x. If you don't put the dot, it's going to say 93 and 37, which is totally not what this means. Go ahead and do your order of operations. So this is 4, 2 times 2. Copy the rest. I'm going to do both multiplications at the same time. You don't have to. You get 27 minus 21 there. Go in the order that you see it, left to right. So 4 plus 27, it's going to be 31 minus the 21. Final answer, 10. All right? So quick recap on that part. Variable next to number means multiplication. Do not forget that. That is the big idea here in questions 4 and 5. For some context, evaluating expressions is usually used when substituting values into geometry formulas. For example, one that you might know right away, area equals length times width. So just an interesting one is to look at the area of a square, because when you do the area of a square, technically it's length times width, but squares have all the same side lengths. So we can actually use the formula A equals S squared. Side squared because it means side times side. So for all of these, they're squares. So if this is 5, this is 5. This is 11, this is 11. This is 16, this is 16. So for all of them, we can just plug it right into the formula without writing out this step. We can say this area is 5 squared. This area is 11 squared. This area, 16 squared. And we could go through and we could multiply those all out, or even if you had a calculator, there's a button that does squared. So you wouldn't even really have to calculate it. So 25, this one's going to be 121, and then here we're going to get 256. Okay, and not to talk about it too long, but technically for the label on all of these, we would write centimeter and then put a little 2 for squared to show that it was an area. Centimeters squared. And we'll talk more about that in some later units, so don't worry too much about it. For this last set of 4 examples, we're only going to do 2. We're going to do one with area and one with volume. Whenever you do geometry, you need formulas, and you can see it right here in the instructions. There are 2 formulas. The area one is not one that we've actually talked about yet, so I'm going to fill in the one that we're more comfortable with, which is area equals length times width. We will talk more about that other one in the geometry unit later in the year. So the formula we're going to fill in for this first one is area equals length times width. And if we're going to fill in that expression, it's just L times W. So we need to know which one is L and which one is W. I'm going to call this the length L and this the width W. Remember, it doesn't matter what order you multiply in. You'll get the same answer either way. So if you flip-flop those, it would be okay. So fill it in to substitute, and you're going to get 2.7 times 6. And if you do that math out, you get 16.2. And same as before, centimeters squared because it's 2-dimensional. And for our last example, this one is 3-dimensional. So we're going to use our volume formula, length times width times height. Expression for that would just be the length times the width times the height. Expressions do not have equal signs. We'll talk about that more in the next unit. To solve it, we have to evaluate it and fill it in. So I'm going to say this is the length, this is the width, and this is the height. Again, it's multiplying, so the order doesn't matter. So I'm going to say L was 9, W was 3, and then H, I'm filling in the 14.5. Pop that into a calculator, and you're going to get 391.5. Now this one is 3-dimensional, so it's inches with a 3 as the exponent to indicate 3-dimensional. And that's it for evaluating expressions.